Right, we'll just carry on with that. I think I accidentally stopped it. So that there is the answer there. Right, okay, here. In some people, the lens can become cloudy. This is called cataract. How will the cataract affect the ability to see? So there's less light gets into the eye. So less light gets into the eye. So less light hits the retina. Or the fovea. So there's 4 impulses to be sent to the brain. So let's just put this down. No, let's not do that. So less impulses to the brain via the optic nerve. This is a maths question. They're saying you've got 322 million people in America. 47% are over 40. 17% of those over 40 develop cataract. Calculate this, a maths question. Okay. So you've got 47%, and then you've got 17.2% of that, and then you've got 322 million. 1, 2, 3, 4, 5, 6, and that's the answer. I'm not really worried about that. So that's a maths question. So they want 17.5% of 47% of 322 million. Right, okay. Cataracts develop when proteins in the lens lump together. Lanosterol. Okay, I'll eventually pronounce it. Lanosterol. It's a chemical that helps break up these clumps of protein. In 2015, scientists investigated the ability of lanosterol to cure cataracts. They put drops of lanosterol solution into the eyes of rats with cataracts. After 6 days of treatment, they counted the number of rats with the clear lens and the number of rats that still had cataracts. So, number of rats, clear and cataract. One conclusion from this investigation is that lanosterol cures cataracts in humans. Explain why some people might agree with this conclusion. Because more, well, not people, more rats had clear lenses than with cataract. Right. Give 2 reasons people will not agree with this or may not agree with this. Right. There was a small sample size. Right, so you need a large sample size to be convinced that it works. Secondly, some of the rats were not cleared of cataract. There you go. Right, you've got all this going on. A is, let's go through this. A is what? The retina. Ooh. I'll have to look up B. Okay, that's the retina. This here is the fovea, and it contains what? Rods which detect black and white, is to do with sharpness, night vision. Cones is for color, and it's for daylight. At night you're not going to see any color, it'll be just black and white images or gray images. We know this is the lens. You know that this here is the iris. You know this here is the cornea. Let's write cornea. That no, yes, right. That is the ciliary. Let me spell that again. Ciliary muscle or ciliary body, and then you've got suspensory ligaments here. Suspensory ligaments. Right, we need to look at E and D. Right, this here is the conjunctiva. Right, they're saying that D is the cornea. I don't know if E is pointing to, so let's rub this out. I don't know whether E is pointing to the iris. So D is the cornea, that's what they're saying, cornea. That makes sense. Right, B is the inside of the eye, and it's got a jelly-like substance. So D is the cornea and B contains the jelly-like. And the function of A is it sends double signals, say impulses. Better still, electrical impulses to the brain. Okay, let's move on. Right, let's have a look. So you have a detached retina. So a detached retina means less signals to the brain via the optic nerve. And I would be inclined to change the word signals to electrical impulses. So if there's less, whoa, you stop that. If there's less electrical impulses, the quality of the image formed in your brain will be lower. Right, and what will that lead to? Poor vision. So poor vision will get you your second mark or your first mark. So you'll end up with poor vision, not clear image. Why? Because there's less signals or impulses to the brain via the optic nerve. Right, okay, that's fine, we've done that. Right, that's the eye done.